circular motion. Circular motion. All right, so when you talk about circular motion, what should come into mind? Actually, let me make it circular and rotational motion. Circular and rotational motion. Actually, do not be confused. Circular motion and rotational motion are different. Okay, we'll be talking about these ones. Yeah, good. Now, when we first talk about circular motion, we say a motion. Circular motion is the movement of a body or particle in a circular path. Okay, circular motion is the movement of a body or particle in a circular path. So when you take an example of, let's say, circular motion, you have a merry-go-round, you have the satellite in its orbit. Okay, the satellite in its orbit moving around the earth. You also have a string tied to a stone at one end and wheel round. Okay, so it is an example of circular motion. So, well, let us first consider, let's say, a stone tied with let's say a string and then wheeled around. Okay, so assuming that this is let us assume that this is the part. Okay, and this is the body, and this, let's say, the string. All right, then this is the stone. Are you following? Now you are saying that it's moved in the circular path. Good. So now, therefore, let us derive a formula over here. Okay, good. Now let us assume that the stone is wheeled from, let's say, position A to, let's say, another position B. All right, in this case, what do you observe? You observe clearly that it has made a certain, it has occupied a certain displacement over here, which is an angular displacement. Now it is making an angle of theta. Are you following? Now, as it is making an angle of theta, we are saying that this is equal to the radius at which the body is negotiating the curve from the center. Okay, now this is also the angle, and this is simply the displacement, which is your S. Okay, so now this is the angular displacement by the stone, and this is the radius, which is constant throughout. Okay, so now over here we can try to derive some formula, which is called a derivation of form line. Okay, good. Now from here we can say that this is okay, so let us try to derive some formula over here. Let us try to develop some formula over here. You have to also have in mind that this is called an angular displacement. That's any displacement in a curve or in a circular path. All right, that's called an angular displacement. Good. Okay, so good. So the radius can also be here. Now let us derive a formula. Over here, from this you can simply obtain that from trigonometry, sine of the angle theta equals the opposite over the hypotenuse, which is your S over over R. Is that not it? So sine theta equals S over R. Now for small angles, okay, sine theta for small angles, okay, sine theta is approximately the same as theta. Okay, good. For what you mean is that for small angles, okay, sine 0.1, for instance, is just equal to 0.1. Okay, that's for small angles. Over there is a small angle over here, so we are saying that sine theta is approximately theta. So we simply substitute that into it. We are therefore going to have theta to be equal to displacement over the radius. Good. So that's what we are having. So where S is the distance traveled and R is the radius and theta is the angular displacement. Are you following? Good. So now, but we all know that, okay, so from this you can also say that it implies that there's angular displacement equals theta R. Let us call this one equation 1. Okay. Now, we also know that when you consider, let's say, when we are considering the distance, okay, around, let's say, a circle, all right, where we are talking about circumference, we can also say that this displacement, this slight displacement, is a part, or it is part of a circumference. Are you following? This small displacement is also a part of what? A circumference. Now the formula for finding circumference is C equals to 2 pi what? 2 pi r. So now, should this be the formula for finding the circumference? Okay, and this also be the formula for finding what? The slight what? Displacement. Okay, then it therefore implies that we can equate equation 1 and what? Equation what? 2. So out of this, you can just derive that theta r equals 2 pi what? 2 pi r. So now out of this theta and this theta can cancel out. We will therefore be having theta to be equal to what? 2 pi. So now this is called 2 pi what? Radian. Good. 2 pi what? Radian. Now you ask yourself the question, what is a radian? A radian is the angle subtended at the center of what? A circle. Alright? It's the small angle subtended at the center of what? A circle. That's what we refer to as what? Radian. Because this is the smallest angle subtended at the center of what? The circle. So we call it what? Radian. So let us take an example. What is the angular displacement? Okay. First question. What is the angular displacement in radians when an object moves through 5 meters in a circular path of radius what? 2.5 what? Meters. So from this question, we can simply deduce the parameters. Okay. They are saying that what is the angular displacement? So we are looking at what? S. We don't know S. In what? Radian, when an object moves through what? 5 meters. Okay, what's the angular displacement in radians? Good. So it means that what are you looking for? Good. We are looking for this. All right. Good. So we are looking for that theta. So this is the formula for finding the angular displacement in what? Radian. All right. Good. That. So now, out of this, we also have our S towards, our S is what? 5 meters. And our R is what? 2.5 what? Meters. Good, because the question was stating that what is the angular displacement in radians? Okay, he didn't say find the angular displacement S, but I said that what is the angular displacement in what? Radians. You know, this is the radian, which is the angle subtended at the center of what? A circle. That's what you're supposed to find for. In a circular part of radius what? 2.5 what? Meters. So now we have to find for the angle what? In radians. So theta equals what? S over R. So this is equal to what? 2 what? Radian. Good. Let us take another last question. Now, before we take the last question, okay, this is therefore, you see, theta equals 2 pi radian, okay, it's for one complete what? Circle. Do you know why? This is because by relativity, circumference equals 2 pi r, okay, is for the whole 360 what? Degrees. That's when you consider, let's say, a circle like this of a particular radius what? R, okay. You know, this radius is constant throughout. So if you are to, let's say, find for circumference by using 2 pi r, it means that you are finding for the circumference of the entire circle, which is equal to 360 degrees. Okay. So now, as this circumference was used in the derivation over here, this formula for finding radian, which is theta equals 2 pi r, okay, is for what? The entire 360 degrees. Now you have to also note the time that you should use theta equals S over R and theta equals 2 pi r. Watch here. In any question, if the displacement is not given and you are asked to find for the angle in radian, then you should be using this one because this is the formula that do not what? Carry what? Displacement. Are you there? Good. So now let us continue from there. Let us take the second question. Now the second question is stating that express angle 40 degrees in radians II revolution. Express angle 40 degrees in radians. We have to express 40 degrees I in radian, II in what? Revolution. So solution. Now to express an angle in radian, okay, what you have to bear in mind is that 360 degrees equals 2 pi what? Radian. Because bear in mind that this theta over here is for the entire what? 360 degrees. So now from 360 degrees equals 2 pi what radian. Okay, 40 degrees equals what unknown, let's say x. Okay, so now x equals what 2 pi radian times 40, all divided by what 360 degrees. So now when you punch this on your calculator and you further simplify, you'll be getting 0.698 what radian. Good, and this is equal to 0.698 what radian. Good. So this is for your eye, okay, and we are done with the eye. Now let us take the second one. The second one is also saying that we should find for it in what revolution. Okay, you also find for it in what in revolution. Now watch here, when you consider this, okay, when this stone moves around the circular part and then come to its initial place again, it has made what a revolution. Okay, so now by what ratio is 40 degrees is relative to what 360 degrees, or one what revolution? Are you following? Good. And so therefore, if you are to find for 40 degrees in revolution, now we all know that 360 degrees equals what one what revolution. It therefore implies that 40 degrees will what? We don't know. Let it be y. Okay. It therefore follows that with respect to 40 degrees, its corresponding revolution is therefore going to be 1 revolution times 40 degrees, all divided by what 360 degrees. Okay, for which when you punch this on your calculator, you are going to get your final answer to 0.11 what revolution. So this is going to be 0.111 what revolution. Good. So that's what you'll be having. Now let us move on to the next subtopic, which is called what angular what velocity. Positive.